In this video, we're going to look at a related rates problem that involves a water tank in the shape of an inverted circular cone with a base radius of 6 feet and a depth of 8 feet. And we're going to suppose that the water is being pumped into the tank at a constant instantaneous rate of 4 cubic feet per minute. So, first thing we're going to do is get a picture of what the heck is going on here. So here's our inverted cone that has a height of 8 feet and the radius is 6 feet. Now something else we know, the water is being pumped in at an instantaneous rate of 4 cubic feet per minute. So that means that the volume, or dV dt, is equal to 4. That is a good thing to keep track of because it helps us with what we're looking for. Now, let's say we have some water in here. So this is going to be the level of the water. Well, the water has some height. We could call it h, and the water has some radius. Let's call it r, because that's going to vary depending on the height of the water. Thus, it needs variables. Well, now for part B, we can come up with a relationship because we have a cone. The volume of the water is pi over 3 r squared h. So what this will do is this will find the volume of the water at for any given radius and height of the water. Now what we want to do is get volume as a function of either r or h. So what we're going to do is we're going to use the fact that if we look at our cone directly from the side, and we have distance of 6 there and a height of 8, and then we've got another triangle in here, r and h, we have similar triangles, which allows us to establish a relationship. For instance, r is to h as 6 is to 8. Now this is something we can solve for either r or h. In this case, I'm going to solve it for r to get this all in terms of h. So r equals multiplying both sides by h, and this can reduce down to 3/4 h. Now what I'm going to do is use that to get my volume all in terms of h. So I have pi over 3 times 3/4 h squared times h. Alright, and now this all gets squared. You got to be careful here. I'm going to have pi over 3. This is going to be 9/16 for the fraction, and this will be an h squared times h for an h cubed. Do one more step of simplification because I'm going to cancel the 3 out of here. And we're going to rewrite this guy as 3 pi over 16 h cubed. Alright, so now we have volume as a function of height only, instead of being of a radius and height. Because of the similar triangle, this relationship will always be true. What that allows us to do is now get a relationship between the rate the volume is changing and the rate the height is changing. So we're going to differentiate both sides. Let's rewrite this so we can see this. 3 pi over 16 h cubed. So the left-hand side becomes dV dt. That's the derivative of v with respect to time. Over here, this is going to be a power rule, and then a chain rule involved. And so just think of it as a power rule at first. So 3 pi over 16, now here is our power rule, 3h squared, the derivative of h cubed. Now we have to multiply by the derivative of the inside, dh dt. Now remember what we knew about this. We knew dV dt is equal to 4. So we're going to do a little bit of simplifying, and then we're going to be able to put 4 in for this side to go ahead and answer the remaining parts. So dV dt is 4, and we have 9 pi over 16, multiplying the 3's together, h squared dh dt. Now what we're going to be asked to find is what the rate the water is changing when it's 3 feet deep. So in other words, when the height is 3 feet. So we're going to solve this for dH dt first, just to see what's going on. So that's going to be multiplying by the reciprocal. So we're going to have 64 over 9 pi h squared on bottom. Okay, now notice what's going to happen. As the height gets higher, the rate the height is changing slows down. So we see that from our formula. Well, let's think about that. That makes sense because as we get higher in the cone, it takes more water to move the level up higher because the cone is getting wider. So this makes sense that this would be happening. So now let's go ahead and do this at 3, for instance. So when h equals 3, we get 64 over 9 pi times 3 squared, or 64 over 81 pi. And the units on this, because it's height, it's going to be feet per minute. Again, we know this because our volume was changing at 4 cubic feet per minute. Now we can answer, and we can go ahead and find the rate that the height's changing for other heights just using what we found right here in part E.